Welcome to EPG Pathshala in Computer Science. This is a series of lectures on computer networks. So, we have been looking at multimedia networks and multimedia applications and what is the kind of support that multimedia applications require from the network perspective. So, we have been looking at a number of protocols. So, in tune with that we will be looking at some session related protocols today. What we will specifically look at will be on sessions management, what is the motivation and what are the protocols that are used for sessions management. And we will look at two protocols out of that. One is called the SDP protocol, the other is the SIP protocol, SIP protocol. So, what is the motivating scenario when you look at these session control or call control kind of requirements? So, let us say you have a video conference, you want to hold it at a particular time and you want to make it available to a wide number of participants. And you have decided on what kind of encoding you will use. So, let us say you will use some MPEG-2 encoding or for the video and you will send it to a particular multicast address. The multicast address is also decided and that you will be sending it using RTP over some UDP and at a port number. So, these are the specifications of when and where your program is going to be broadcasted or sent, okay, multicasted actually. Okay. So, the question that comes up is how do you make all this information available to the intended participants so that they will be able to set up the required parameters on their side and connect with your application. So, this is what we are trying to look at when we talk about sessions management. Now, the IETF standard, the Internet Engineering Task Force, they have defined a number of protocols for sessions management. So, we have something called the session description protocol, which is SDP. Then we have something called session announcement protocol, SAP. And then we have something called a session initiation protocol, SIP, and then we have something called SCCP, which is simple conference control protocol. So, of this SDP is used to describe the parameters of a session and SAP, the session announcement protocol, is used to announce that information. Okay, it is just used to pass it on to the rest to the entire group. So, normally SAP is a very simple protocol in the sense that it just announces whatever information is there about a particular session, whatever description you have about a session. It just announces that to the same multicast address to which the conference is going to be multicast, to which is going to be sent. So, to the whoever the users are, whichever is the multicast group address, which is the group address of the users, to that same address you will be sending the announcement. So, that is the announcement protocol. And the idea is that you will keep announcing it periodically so that people will be able to get the announcement and accordingly they will be able to log into the session. Then we have the session initiation protocol, which is the main protocol which is actually used to establish the connection and then get the transfer of data done, and then finally that connection will have to be shut down or teared down. Okay, so, that is what we need to do. Then we have something called a simple conference control protocol that is used for conference control as such. So, of these we will be looking at two protocols, that is the SDP protocol and then we will look at the SIP protocol, SDP for session description and SIP for session initiation. Okay. Now, when we talk of session description, there are a few terms that we kind of tend to keep using. So, it is better to take a look at these terms. We talk about something called a conference, right. So, this is just a set of two or more communicating users along with the software they are using, and a session we refer to a multimedia sender and a receiver and the flowing stream of data. A session announcement, it is a mechanism by which a session description is conveyed to the users in a proactive fashion, that is even if it is not explicitly requested by the user. And a session advertisement also has the same purpose as the session announcement. And we talk of a session description, which basically gives you the description of the session in a well defined format, so that all the participants will be able to get the information correctly. So, now we come to the SDP protocol. So, the SDP session description protocol is a general protocol that is used for describing the session, and typically it is used in conjunction with one or more other protocols such as SIP. Okay. Now, the kind of information that will be conveyed by an SDP protocol are the following. It has the name and purpose of the session, the start and end times of the session and the media types. For example, what kind of audio, video that actually comprise the session. And there will be detailed information that is needed to receive the session, that is the multicast address to which the data will be sent, the transport protocol to be used, the port numbers to be used, the encoding scheme to be used, all this information will be present in the session description protocol. Okay. And the whole thing is specified in a text format and completely gives a description of the multimedia sessions. Actually, it is not a protocol as such, because it is just used to convey some information. You can look at it more like it's very similar to a markup language such as HTML. So it gives you a particular format in which the content or the description has to be sent to the receivers. Okay. And as we said, can be carried in any protocol. It can be carried in an RTSP protocol or a SIP protocol, and it describes the unicast and multicast sessions. And when we describe a session, the caller and the callee, right? So they will indicate their respective receive capabilities, media formats, and the receive address port. So this can be used to kind of negotiate the parameters between the two of them. So that's what the SDP will be allow you to do. Okay. So an SDP message as such, we say consists of 3 levels of information. One is a session level description, the other is a timing description, and the other is the media type and format. So session level description will give you the information about the session identifier and other session level parameters such as IP address, subject, contact information about the session, who is the creator of the session, and so on. So timing description will have information such as the start time, stop time, repeat times is going to be repeated, and some more other media level descriptions, and then you have the media type and format. So these are 3 different levels of information. Each of them have many parameters that will be specified. So the SDP message, if you look at the message as such, basically a collection of SDP lines, and there is a very strict syntax that is followed, and all lines have the same format, okay, which looks like this. So the format has this format, character equal to value, okay, that is the format that is used, and the value will consist of a number of parameters, parameter 1, 2, 3, etc. up to parameter n, and that will and the parameters here will vary depending on what this character is. Okay, so we will take a look at that a little more in detail. And each SDP line will end with a carriage return line feed, right, so that you have a distinction between these different lines as such. Okay. And the 3 levels of information that we talked about, right, they should appear in that particular order. So that also is mandated by the SDP syntax. So if you look at the message contents, we said that you can have a session description would be there. So that will consist of these different fields. So you have a V field which indicates the protocol version, O which indicates originator and session identifier, S stands for session name, I will give you some session information, U will give you URI of the description, E will give you email address, P will give you phone number, C will give you connection information. It is not required if included in all media, but otherwise the connection information will have to be specified. And then you will have B which gives you 0 or more bandwidth related information lines. Okay. And there are 1 or more time descriptions could be there. You can have a T line or an R line or a Z line, a K line, and so on. Okay. So this is basically the kind of fields that you will find in an SDP message. And whenever we have the connection line, the C line must be either present at the session level or the media level. So it must be present at the media level if it is not present at the session level. Now we said that there are 3 levels, right? Session level, time level, and then the media level. So it should be present in one of these 2 places. So if it is present at both levels, then the media level connection information will override the session level information. So the connection information will tell you what type of network is being used, what is the address type. Typically what we use is internet, so it will be indicate that it is type is internet is the type, and address type would be whether it is a V4 address or a V6 address, and that will be followed by the network address. So this is used to give the network connectivity kind of information. Okay. So then looking at the time description part of the SDP message contents. So T gives you the time the session is active, and we said you can have R which is 0 or more repeat times. So you will have a T and an R to give the description of the time. And then there is a media description. So if this media description is present, you will have information such as M which will give you what is the name of the media and the transport address, and then you have the media title, and then you have C which gives you connection information. We said that this is optional if it is already included at the session level. And there is again B which gives you 0 or more bandwidth information lines. K gives you encryption key if there is some kind of encryption being used, and A gives you 0 or more media attribute lines. So specific to the media there may be other attributes that need to be specified, they will be specified as A lines. Okay, so these are the different lines that need to be present. So if there is a media line, this is an important parameter, so we will just take a look at that. So the M line will have 4 parameters. It will have the media information, port information, transport information, and the format list. Okay. So the it will give you the type of media, namely whether it is audio, video, game, and so on. and the port number, that will tell you the port number where this media can be received. The transport information will specify what transport protocol is being used, whether it is UDP or whether it is RTP that is being used with audio video profile. Okay, so what is it that is being used? So RTP/AVP indicates that you will be using real time transport protocol with audio and video profile. And format list will contain more information about the media, usually some kind of payload types which are defined in the RTP and AVPs. So that is the kind of information you will find in the media line. And if the transport is RTP or AVP, it means that it will use RTP and RTCP. So remember that RTCP is a protocol that is used for control information along with RTP protocol. So if that is used, the RTCP protocol port number is always treated as RTP port number +1. Now we know that RTCP is assumed to be sent whenever RTP is carrying media, and the RTP port number must always be an even number. So the RTCP port number will be the next odd number that we have. Okay, this is how the media line will be specified. Now coming to the attribute lines, which is again part of the media description. So the A line will define the various attributes of the media. It can be a session level attribute, it can be a media level attribute, or both. You will have something like this. Attribute interpretation will depend again on the media tool being invoked. So you will have A equal to and an attribute field followed by some attribute values. For example, you can have something like A RTP map and specify payload type, encoding name, clock rate, okay, encoding parameters. These are examples of what could be specified as part of the attributes for the media that is being specified. So this is an example of an SDP message. So you can see that this is what the whole thing will look like. So you have V equal to 0 indicating that the version is 0, and then you have an O, and then we have the S, gives you the name of the session, then there is a connection information, you have the timing information, then we have media information. So media information specifies that you can see that there are two M fields here. Right, so which indicates there are two types of media that are being carried in this session. One is an audio and other is a video. And for audio you have this information about what is its transport mechanism and so on. So RTP/AVP. That is followed by certain parameters, right. So if you look at this, we have an attribute that is being specified for this audio. In fact, you can see that there are 3 attribute files, which indicates that there are 3 different encoding schemes that are actually being used: PCMU, PCMA, ILBC, and so on. Okay, so you have information related to that being specified here, followed by the other corresponding parameters. Okay, so similarly there is a video that is being used, right. So that is information corresponding to the video is specified here and an attribute for that video. So you have information that is kind of specified like this. So this is basically what an SDP message will look like. So you can see that by just looking at the message, you will be able to identify what are the various parameters that will be used for the to describe the media that is being transmitted, along with all the information such as the multicast address, what is the addresses to be used, and port numbers to be used, protocols to be used, and so on. So complete description of that session would typically be present in the SDP message. Now moving on to the session initiation protocol. We said we will be looking at 2 protocols. One is STP, which is what we looked at now. The other is the session initiation protocol. This session initiation protocol is meant to be something which allows sessions to be introduced or sessions to be established for any caller to be able to talk to any callee. Okay? So in fact, the long term vision goes like this. We would expect that all telephone calls and video conference calls can take place over the internet. So people could be identified by names or email addresses rather than by their phone numbers. And you can reach the callee if the callee so desires, no matter whether the callee is roaming or no matter what IP device the callee is currently using. He may be using a cell phone, he may be using a smartphone, he may be using his laptop, whatever it be, you should still be able to reach him. So these are various things that have to be kind of handled by the session initiation protocol. So whatever be the situation, you should be able to establish a session and you should be able to carry out the conversation, carry out the data transfer. Okay. So this is described in RFC 3261. Okay. So if you look at the capabilities therefore of the SIP protocol, you can look at it in terms of 5 different categories. One is it should give you information about the user's location. So user location, that is determining the current device with which to communicate to reach a particular user. So where exactly he is located. Then comes user availability, determining if the user is willing or able to take part in a particular communication session. Then user capabilities, that is determining such items as the choice of media and coding scheme to use. Then session setup, that is establishing the session parameters such as the port numbers to be used for by the communicating parties. And then finally session management, which is the range of functions including the transfer transferring sessions, okay, call forwarding for instance, modifying session parameters. Okay, how do you manage certain parameters when the session is in progress? So these are the various capabilities that are kind of built into the SIP protocol. So we will take a look at how SIP is able to handle all these things in a very simple manner. Okay, so if you look at the session initiation protocol, we said that it handles things in a very simple manner. So simplicity is one of the major characteristics of the SIP protocol, and then it also has compatibility with other protocols which are already currently existing. So it is used to characterize a multimedia session, and it will work along with the supplementary protocols such as SDP and SAP protocols. What is very interesting about the SIP protocol is that it has very HTTP-like characteristics. So it is basically a text-based protocol as you have in HTTP. So the message syntax and the header fields are all very similar to HTTP 1.1, and it works in similar to a client-server scheme of operation. So that is the way the SIP protocol has been designed. Okay. If you look at the services provided by SIP, you can see that it provides mechanisms for call setup, for the caller to let the callee know that she wants to establish a call, so that the caller and callee can agree on the media type, encoding and so on, and then to end the call. So call setup and call ending, that is supported. In addition to that, determine the current IP address of the callee. So it maps the mnemonic identifier of, you may have either an email address or a name that is used, that is identified to the current IP address, and it allows you to do call management. That is, you can add new media streams during the call. Even as the call in progress, you may have started with the audio call, you may want to add video to it, or you can change the encoding during the call. Okay, you might invite others during the call, you may be able to transfer calls, hold calls and so on. So all kinds of call management facilities which you normally expect in any, for instance, any audio conference or a video conference kind of a call, all those things have to be provided, and all these are provided as part of the SIP protocol. Okay, so we say that these are all the various services offered by the SIP protocol. Okay. So if you look at the elements that we have in a SIP environment, so you will find that there is something called a user agent or a client. So it is called as a UAC. So this you can look at as a SIP client, and the SIP client can talk to a user agent server, UAS, which is the SIP server, okay, so to say. So now the client would be typically connected to the server by means of a local proxy server and a remote proxy server. Okay, these are possibly some proxy servers that could be there in between. So these are certain terms that we talk about, and you can have something called a redirect server, and you will have something called a location server. So we will, as we look at the details, we will try to take an we will get an understanding of the role of each of these things. Okay, and if you look at the protocol stack of SIP, how is it expected to work with the other protocols? So you will see that SIP works with the help of your SAP, the announcement protocol, the description protocol, and runs on top of TCP, okay, and UDP. It can run, okay, so this forms kind of the control plane for the data transfer to take place. Now the data plane would consist of multimedia traffic, which is being carried by over RTP and RTCP, which is being carried over UDP and over the IP protocol. So over the IP on top of TCP and UDP is where we have the SIP and the other session related protocols that run. Okay. Now we said that the messages that are used in SIP are very similar to the HTML messages, so we will take a quick look at that. So the different messages that we talk about, we have something called an invite message, which is used to invite a user to a call. And then you have an acknowledgement ACK, which is the confirmation of the response. And then there is a BY, which is used to terminate a call between two endpoints. So invite, ACK and BY are three things to use for this purpose. Then you have additional messages like cancel, which is used to terminate the search for a user or a request for a call. And then you have other options which could consist of other features that are supported for a call. And there is something called a register message, which is used to register the current location of the client with the location server. Remember, we talked about something called a location server. So there is something called a location server which is available, which will keep track of the user's location. So how will the location server know that information? The user will have to register himself or herself with that particular location server. So for that we have a message called the register message. And then there is an info message which is used for mid-session signaling, some information that needs to be passed on when you are in the midst of a session, then we have an info message that is used for that purpose. So these are the different messages that we have in SIP. Okay. And when you give these are, so you can look at these as methods as corresponding to the methods that we have in HTTP. So similarly you will have status responses that come from HTTP. Similarly we have reply codes in SIP. So reply codes have this particular format. If the code is 1 followed by XX, some number, it indicates it's some informational kind of a message reply. So information like something, it's trying for something, or it's ringing, or it is queued, that kind of information is specified in 1XX kind of a reply code. 2XX, for instance 200, indicates that it was okay, it was successful, the request was successful. 3XX indicates redirection, that is you are giving information about the receiver's new location, you are redirecting this call to some other location. And 4XX request a failure, so it indicates that it's a failure response from a particular server. So remember in HTTP we have 404 which indicates a server, right, page not found. So similarly 4 followed by something, 2 other numbers will give you some failure kind of information. And 5XX indicates server failures, and 6XX indicates some global failures. So busy or decline or requests are not acceptable kind of messages are specified over here. Okay, so these are the different reply codes that we have. So an example operation in SIP, it would go like this. So the user access the client that you have will invite the server with a SIP URL, okay, and it will specify the destination IP address. So the destination IP address may be known or it may be unknown. Okay, so if it is known, then this request can be directly sent to that destination. If it is unknown, then it will be redirected to the local proxy server, which may be located along with the location server, or which will talk to the location server and get some information. Now there are 2 modes possible when the destination IP address is unknown. So we have something called a redirection mode, in which you will send back the callee's new location, you are redirecting it to this. The other is called as a proxy mode, in which it will forward the request to the destination. Okay, so you can see that there are 2 modes, redirection and proxy. So in redirection you send back information about the callee's new location. In proxy, the proxy server will take care of forwarding the request to the destination. And the server, the UAS, typically will answer with 200 OK, indicating that things are okay. If it gets these OK, and then the client will send an ACK. So once this is done, the session will be established. Okay, so this is the basic flow that you will have in a SIP message. So this is just to give you a view of this flow in the form of a timeline diagram. So you can have, for instance, so I have some bst-pc.cisco.com who wants to invite, somebody at princeton.edu. Okay, so what happens here? He sends an invite message. So this goes to the cisco.com proxy, right? Because he does not have the IP address. So he just gives this information. It says invite and just gives the name of the person, let's say. So it goes to cisco.com proxy. So cisco.com proxy now will send that invite message to princeton.edu proxy, which in turn sends the invite message to the ph.cs.princeton.edu. Okay. Now what will happen once the invite message is sent, it will ring at the other end. So a ringing message, 180 ringing, right, will be sent back here, and that ringing message will be passed on right up to the client who initiated the call. Meanwhile, you can see that from the proxies you have a temporary response which is coming back called 100 trying, which indicates that it is trying to establish the call. Similarly, from this proxy also you will get a response saying it is trying to establish the call. Okay, so these are intermediate responses which are sent back by the proxies. So once the ringing tone is received, okay, once then the call is picked up, so then it sends an OK, so 200 OK response, which is passed on by the proxies to the caller, right, and then the caller sends an ACK to the callee, an ACK saying that it's accepted the OK. Once that is done, they can exchange media information directly between the caller and the callee, right, and then they can transfer the data. Once it is done, it sends a bye, and this sends back a 200 OK, and that terminates the session. So this is the overall flow that you have in a basic SIP session. Okay. So we just looked at an overall flow. So now let's look at some details of how the information will be passed on when you are setting up a call to a known IP address. Okay. So I have Alice calling Bob, let's say. So so Alice will send out what's called as an invite message. Now this invite message will have information about we have said it's to a known IP address, so it has information about the IP address of the callee. So it says invite Bob at, and gives you the complete IP address information here, right. So give the IP address information, and then you have some connection information that's being specified. You can see that you have these SDP protocol kind of information that's being carried over here, right. So you can see that I'm specifying the connection parameters, specifying the media parameters. Okay, so it's saying that I'm willing to receive audio of this particular format. Okay, so the RTP AVP format is what I'm willing to receive. Okay, that information is being sent here at port number 5060. So now the Bob's terminal, okay, he gets this message that he'll get a ringtone at his end. Once he gets that ringtone now, he will send back an OK, indicating that he is willing to take the call, right. So you can see that. So Alice had sent the SIP invite message indicating her port number and the IP address and the encoding that she prefers to receive. So maybe she specifies PCM, MULA or something like that. Now Bob's 200 OK message, you can see that this OK message will also have some information about the media to be used, and here he will specify his preferred encoding, right. So that will be also specified. Now you can see that an ACK will be sent back. Once the ACK is sent, now you can start sending the information. You can see that from here to here, right, from Bob to Alice, that is from the callee to the caller, you are using MULA audio. From here to here you are using GSM audio. So which means the two entities can decide to use two different encoding schemes for their respective data transfers. See, it gives you a lot of flexibility in terms of how you can actually do the data. It is not necessary that both of them have to agree on the same thing. They just have to agree on the fact that if you send in a particular encoding, I can receive it, and if I send in a particular encoding, you can receive it. So once that is done, alright, so then they can start receiving this information. And you saw that we kept having this port number of 5060, that's a default SIP port number that is used. Okay, so this is basically how the call is set up for a known IP address. Now let us say we have, we need to kind of get a little more information. In this case everything is agreeable, then everything is fine, but it is possible that you may want to negotiate on the codec. Suppose Bob does not have the PCM MULA encoder. So what will happen in that case? He cannot accept the call saying everything is okay. So what he will send is, he will send a reply saying 606 not acceptable reply, okay, that is the reply that he will give, and he will list in that message which are the encoders which are acceptable to him. So once he gives that, then Alice can send a new invite message advertising the different encoder, and then he will be able to complete the call. Okay. Similarly, Bob can also reject the call. It could be rejecting for various reasons. It could be busy, gone, payment required, forbidden. There could be different messages that are used. Okay. Once that is done, you obviously cannot have the call completed. But if you allow the call to get completed, then media can be sent over RTP or even some other protocol. So that is basically what happens. Okay. So this is the example of a SIP message, right. SIP message, you can see you will have invite SIP at something followed by via, and you are specifying what is the address through which it goes. Then is a from message, to message, call ID, content type, content length. You can see that all these are very similar to what you have in a HTTP message, okay. So very similar to that. And then we have this session related information, which is what we already looked at in the SDP kind of a protocol, okay. Right. So in this case, when we said invite SIP at bob at domain.com, you can see that we really do not know the IP address, which is why we have not specified the IP address here. So in which case you will require some intermediate SIP servers which will have to help us to reach the destination, okay. So Alice will send and receive the SIP message using the port number 5060, and Alice will specify in the header that the SIP client will send and receive SIP messages over UDP, okay. So that is what is specified here as UDP, okay. That is the information that we have in this example, okay. Now coming to when we need to do name translation, user location and so on, okay. So what is it that why do we need that, what is it that we need to do in these cases? So the caller may want to call the callee, okay, but only has the callee's name or email address, in which case he has to get the IP address of the callee's current host. Now why would we need this? It may be needed because either the user moves around, so he's got a new IP address, or the DHCP protocol might have given him a new IP address, okay, or the user can have different IP devices, his PC, smartphone, car device and so on. So depending on that, you may want to connect to him at whichever device he is currently using, okay. And what we would also like to do is, when a call is made, the result, right, as to how you want to connect, whether you want to connect or not, could be based on various factors. You could base it on time of day, okay, whether you are work or home, the caller, okay, you may not want your boss to call you when you are at home, right. So that's so you can kind of keep track of whose calls you want to take and whose calls you do not want to take. And then the status of the callee, okay. So for instance, you can say calls have to be sent to the voicemail when the callee is already talking to someone, okay. So you can have some kind of these. So these are all additional features that can be provided, okay. So then there is one more entity called the SIP registrar. We talked about SIP servers, right. So similarly there is something called a SIP registrar that is used. So one function of the SIP server as such is what is called as a registrar function. So what is the registrar supposed to do? It is supposed to register information, and this is done by sending what is called as a register message. So when a user wants to start a SIP client, the client will send a SIP register message to the users, the Bob's registrar server. Okay, so that is done by means of a register message. So register sip:/domain.com specifies information and gives you what protocol is going to use and so on. Okay, from to, okay, all this information is specified here. And another function of the SIP server, as we already referred to, is a proxy server. So when you have a proxy, what is expected of a proxy? Let's look at that. So Alice could send an invite message to her proxy server. So it will contain just the address of bob@domain.com. We just saw an example where some proxy information may be required, right? So the proxy now is responsible for routing the SIP messages to the callee, possibly through multiple proxies. It may not go directly from one proxy directly to the callee. It may go through multiple proxies. We already saw an example of that. Okay. So Bob sends the response back through the same set of SIP proxies. Okay, and proxy returns Bob's SIP response message to Alice containing Bob's IP address. So the SIP proxy can be thought of as being analogous to the local DNS server plus the TCP setup. So both these actions combined into one, okay, that you can look at as the function of the SIP proxy server. Okay, so this is just an example to give you a feel of how exactly connection will take place. So let's say, for instance, okay, so Jim, who is located over here, sends an invite message to UMass SIP proxy. Okay, so it's gives an invite message to this. That is, Jim has to call Keith at poly.edu, and now Jim sends that information. So that basically goes as an invite message to the SIP proxy. So what does the SIP proxy do? The SIP proxy now will forward this request to the registrar server at Poly. So Poly is one we are trying to contact, right? So you forward this request to this registrar here, the Poly SIP registrar. Okay, and so what will the Poly SIP registrar do? It returns a redirect response saying that it should try Keith at eurocom.fr. Okay, so we are seeing that we are having some kind of a redirect information that's being specified here. You forwarded this, right, request to this registrar, and he is now giving you a redirection information saying, don't contact me, contact this registrar. So now this server the UMass proxy will contact this whatever invite message that it got. So it will send it to this Eurocom SIP registrar. So when this registrar receives it, now our callee, okay, which is Keith is already has registered, right, with this Eurocom server, the registrar. So Eurocom registrar knows the address of Keith. So what he will now do is, Eurocom registrar now will forward this invite message that is got to this particular IP address, which is running Keith's SIP client. Now this client will respond, right, with a response message which will be forwarded by this registrar back to this proxy, and the proxy now will forward it to the caller Jim. Okay. When this information is received, the IP address of the callee is now available with the caller. So now what can happen between the caller and the callee? Data flow can directly take place using RTP or RTCP plus whatever protocols are being used. Okay. So you can see that this gives us the complete flow of how calls will be forwarded and transferred and whatever using the SIP protocol with the help of the proxies and the registrars. Okay. So this picture is what you should kind of keep in mind to understand the overall flow of messages that we have in the SIP protocol. Okay. So with this, what we have looked at are these two protocols in this session: session description protocol and the session initiation protocol. So we looked at the format of messages that are used in the session description protocol. Similarly, in initiation protocol, we looked at the various components, the messages, and how the data flows between these various components in order to establish an end-to-end session. So, right, so this is essence of what is required for session management and how the internet has come up with these protocols to support this. Thank you.